ultimately here, we're gonna just play on X and Y intercepts. And so we're only gonna need how many points? 2, and that's all it takes to make a line. You only need 2 points to make a line, and X and Y intercepts are gonna give us those 2 points. So, what's the first step? And then solve for X. I know that we formalized that saying plug in 0 for Y, and so on and so forth. I would just ultimately use that as, if I plug in 0 for Y, I know that that needs to be, 0 needs to be that Y part of my coordinate. Does that make sense?
Yeah.
I don't actually plug in 0 for Y, I ultimately just cover it up. So like, rather than literally plug in 0 for Y, I just cover it up. And what is my equation now?
3x.
So 3x equals 15, solve for X. What does X end up being? So my first coordinate is 5, 0. Everybody okay with that?
Oh yeah.
Everybody tracking where I got that
Cool,
from?
man.
Some are you good?
Um,
Alright, and so the second part tells me to plug in 0 for X, so X is going to be 0 in my coordinate. And then I'm not literally going to do that, I'm just going to cover that part up, and I'm left with
And then Y equals
solve for Y. Y equals,
That really is lazy.
isn't that wonderful?
It's so good.
That's
So much
beautiful.
better.
So,
It's so
Well,
beautiful.
This term, when we plug in 0 for X, 0 times 3 is what? 0, and so basically it's not
It's not there, basically.
Everybody cool with that process?
Definitely.
And so at that point, we take our intercepts. 5, 0 would be right here. 0, 3 would be right here. Next,
the same
arrows.
as before.
isn't that wonderful?
Yes. It's
So much easier. Can you think of a situation where that might not be fun?
If you only have the X or Y.
Meaning you only have,
One.
yes, I agree. Anybody else? When would that not be the best idea? What do you mean by that?
not holding, like if you
Okay.
If it's on a multi, or whatever.
I agree with you, but I explain.
Like, if it's not, if it doesn't go in there evenly, or at least to the point where it's.
Yes. So like for right here, what if this had been 24?
or even not bottom.
The,
X would have been.
X would have worked out nicely, right?
Yeah.
But
5 would 5.
5 would not. And
Only was
so
25.
ultimately, we would have ended up with Y equaling some decimal, and nobody can graph decimals very well, especially on a graph that's small.
Are you
So
sure?
pretty much the only time that this works is when the numbers are nice, honestly, which is unfortunate, but
I know, I wish it would work.
if I'm
all the
feeling
time.
generous, I'll give you numbers that work nice.
Yeah.
Better hope I'm feeling generous Friday. So if the numbers are not nice, what do we probably need to stick with?
Method one.
Nothing more.
Yeah, put it in slope intercept form. Now let's talk about method 2, or sorry, method 3. And we've done this before, but a lot of us are not aware that it's like actual way of graphing a function from an equation.
Method 3.
Yeah, I don't care. Well, I wanted to glue this down in your
Let's glue it down.
monologue. Write it at the top.
Okay.
Okay. We're really gonna enjoy this video.
I know. Hi, William.
Hey, William!
Nobody cares about you, Michael.
Alright, method
I
3.
do.
Hey,
Michael did take this.
stop.
Choose values for X.
What kind of values?
Solve for Y. status coordinates. We've been doing this for a little while, we just haven't really thought about that in the context of the situation. And ultimately, that works for any of the forms, whether you have it in slope intercept, standard, or point slope. If you are at a total loss and you don't remember how to graph any of these equations anyways, you can always pick numbers for x, plug it in, find y, and plot the coordinates. So for instance, if I had this equation, 3x plus 5y equals 15, I can make myself a chart. Pick some numbers. What do we need to make sure we pick?
7.
Whole numbers and positives and negatives, because if we had just used positive numbers, remember we talked about, especially for nonlinear graphs, we only know what part of the graph looks like if we only choose positive numbers. So like I would just always start out with the easy ones, or not start out with the easy ones, but I would just do the same numbers every time. -2, -1, 0, 1, 2.
Yeah.
If I do that, when x is -2, remember we just plug it in and start working. And that sucks, but it'll get you the answer every time. So that would give me equals, what do I do now? That gives me 5y equals 21. Divide by 5.
4 and 1/5.
So 4, I'm gonna go with 4.2. What if we did -1? Same thing, right? We'd plug in -1 for x.
Yeah.
And solve, which is a really annoying process.
No. So
That's why I'm not gonna make you do all of these. Y'all do -1 and 0, y'all do 1 and 2. Alright, what'd y'all get for -1?
1.6.
0, 1, 2. Alright, so obviously we could graph that. Well, look at those numbers. Nice. No.
Nice decimal.
So let's talk about benefits or non-benefits. I don't really know that word right now.
There can be detriments.
Detriments to each one, each method. Which of those is probably going to be the most useful universally?
Method 2.
Three.
Method 1.
Method 1. Why?
Because it always works. It always works. Oh, good, I guess. But
This is generally the most nice as far as actually graphing it goes. It might not be easy to get the equation in slope-intercept form, but generally, it's the nicest as far as graphing goes.
nice.
What do you think might be a bad thing for this particular method? What do you think might be kind of a, I don't know if I want to use that method. Okay, big always gonna put in slope-intercept form correctly? No, that's my one bad thing with this. Sometimes we mess up the equation and then we don't graph it wrong, we just didn't have the equation right to begin with. Alright, what do you think some good things about method two are?
It's super easy to do.
Super easy.
It's great.
Extreme.
It's lazy.
What's some bad things about it?
It won't work most of the time.
It won't
It
work
will
with some
work, it just won't
things.
give you what?
Nice number.
Nice numbers, which could be annoying. And this one down here.
I don't like it.
What's nice about this method?
It'll always work.
It always will work, no matter what equation, no matter what form it's in, whether it's a slope-intercept, point slope, or standard, you can always get a graph using this method. What's horrible about this?
I have
It's a
mine.
lot of work.
Not nice numbers, and it's a whole lot of work. And so ultimately, I'm not gonna tell you which method to use. I don't care which method you use. I want you to use which one you prefer.
Yeah.
Are you okay with that?
Uh-huh.
Wonderful.